Hello guys. So this is the video for clustering data mining task for the customer churn dataset for the telecommunication group. So our group. So right away we start with the Weka. So now we need to focus on clustering on Weka. So open Weka first. Explorer. Open the dataset. So locate your dataset in your computer. Change to CSV because my dataset is that format. And then so this is our dataset. So you can see that there are 3,333 instances with 17 attributes. So this is the attributes. You can see each one of them. So this is what we're gonna look at the most important, whether the customer will churn or not. Churn means that it change to another telco. Now for this one, so a little bit explanation about our dataset is that our dataset does not have any missing data, but I mean low percentage of missing data. So on the international plan, it's only have one missing data, but it does not affect the total the result when we generate the process later. Yeah, let's go through the data pre-processing. So for clustering, we only focus on the normalization because we do not use, for example, the clustering classification. We use the discretization, but for Weka, it can handle the numerical value. So we do not need to convert into the range of the nominal value. Attributes. Normalize. Select all the attributes and then apply. Okay, done. So move on to the cluster and then choose your algorithm. So for the first one, we're gonna do the simple k-means. K-means is that the most general one we use for clustering. So right away, use training set and then start, and then we got this kind of result. I'm sorry, we're supposed to change the number of clusters because cluster for the k-mean we need to predefine the number of clusters. So the better use not too big and not too small. So 5 number of clusters. So once again, delete the earlier one, and then this is you can see that this is the 5 cluster 0 to 4, and then you can see the clusters centroid. So for each the centroid, this is the value, and then how to analyze this is that this is the important attribute. So you see that all the cluster is false for the churn, but for the 4 is true. Means that the customer for cluster 4 probably higher probability to churn. So as for the marketing analysis, so you need to focus more on the customer on the cluster 4, and then cluster 4, and then you need to provide some rewards. I mean, maybe some free airtime, means that you give free calls to the customer on cluster 4 so that they will change from true to false. And then that's all we can say about k-means, because cluster is only a descriptive analysis. So the second one, we use the em start. Oh, sorry, training set. Start. I'm gonna pause the video for a moment until it's done processing. Before we start the EM algorithm for the Weka, you need to predefine the number of clusters first. Remember, this is very important. So start one more time. So we wait until it's finished loading and then continue the video. Done with the EM algorithm. So this is the result for the EM algorithm. You can see that there's additional information for the numerical attributes, that is the mean and standard deviation. So it's cluster according to this one and provide the mean and standard deviation for each of the cluster. Each of the attributes. So we can see the results ends with the cluster 1 below than 2% of the instances cluster under cluster 1. So that it's the k-means is better, because even though the cluster 3 is 3%, but it's better than 2% for the EM algorithm. So the third one is the cobweb. So the cobweb is, we do not need to define the number of clusters, so it's gonna automatically generate the number of clusters for us. So start. So wait for it to finish loading. Yeah, finish. So we can see that there are 13 number of clusters generated, but but below it does not define the cluster 1 and cluster 0, because it's maybe due to the it's bigger. Maybe we can see that better in the cluster assignment. This is to change the noise so that you can see the distribution better. Cluster 0, there is no instances in cluster 0, maybe that's why it's not show any instances. It does not display anything on cluster 0 and cluster 1. So that's all for Weka. So after we saw this kind of result, so we can see that k-means is the best one to analyze this dataset, because it has better result. This one is low, but it's better than EM and cobweb. Cobweb has 2% for cluster 2, cluster 1, and EM, and the cobweb has 1, 2, 3, 1, 2, 2, 1% of instances for the cluster 5 and cluster 6. So that's all for Weka. So next we're gonna move to the RapidMiner. So in this RapidMiner, first you need to load the sorry about that. So for the RapidMiner, first you need to import the dataset. So CSV file, locate it in your storage. So customer dataset, and then click next. the column expression you need to specify it according to your dataset. So mine is divided by the comma, so comma, and then it's gonna be in the table form. So for the this one, skip command, and then next. And this one no change, and then we don't have any data format. I mean data uh, format data, so no need to change anything. And then save the data where you're gonna save inside the RapidMiner. So just name it as test chain and click finish. Then you have already load your dataset into the RapidMiner. So move on to design. Then search for first is we're gonna use the k-mix algorithm. So you're supposed to main operator main process. Yep. Sorry, I'm just gonna pause this video. Sorry about that. So we're gonna continue. So first of all, this is your main process. So first is load your dataset test chain into this main process. So this is your dataset. So after that, we need to do some pre-processing. So under operators, search for normalization. So this one, and then connect this this dataset to your normalization. So after that, you need to search for uh, clustering. Under modeling, clustering k-mean. So write this k-mean under this, connect this one to clustering, and clustering to output. So finish, and then try to run. Okay, we get some error. So international plan is a nominal value, so we need to change to numerical. Maybe this is the limitation of RapidMiner because we do not have problem for the Weka. So search for numerical numerical. So put before clustering, change normalize to nominal and nominal to clustering, and then clustering to output. Then click run. Wait for the process to finish, and then yeah, this is, oh sorry, before that we need to define the number of cluster. So we make it the same as Weka, so 5 number of cluster, and then click run one more time. Wait for it. Yep, finish. So we'll see that there is the same number of instances for Weka and RapidMiner, but the distribution is for the RapidMiner is more better than Weka because it's, I mean the cluster is very generally proportionate in number. And then you can see the centroid. This is the value of centroid for cluster 1, cluster 0 until cluster 4. And then this is, this one is the graphical one representative of the data. So we move to the second algorithm for the RapidMiner, which is the So delete the first k-mean cluster, and then search for Weka. We do the em for the second one, so search for em on the model, on the modeling cluster, expectation maximization em, and connect these two. So run. So I already did this process, so it's gonna take a longer time, so I'm gonna pause this video one more time. After waiting for a while, so this is the result. I already run this algorithm many times, but still got the same error. There is all of the instances is under one cluster. For this it's under cluster 1, but now it's under cluster 4. But I don't know, maybe some error that we do not notice. So move on to the third one. Is for Weka we did the cobweb, but for the RapidMiner we do not have cobweb, so we choose k methods. So link this one to this one, and then to finish, and then click run. So I'm gonna pause this video one more time. After we finish, then we're gonna continue. Sorry guys, my RapidMiner has crashed, so I can say that this is the result of RapidMiner for the k-methods algorithm. So the cluster model is slightly shift towards the cluster 3. So many instances are cluster under cluster 3. So we can conclude that once again k-means is the best algorithm to analyze this dataset. So comparison between Weka and RapidMiner for the k-means, because we can only compare k-means because the results shows k-mean is the best, shows the best result. So to compare it by the result, we can say that RapidMiner is better for the k-means result, because the result is well proportionate compared to Weka, because Weka has like low instances for the cluster 3, but for RapidMiner all of the cluster is about the same number. So that's all for clustering for Weka and RapidMiner. Before that, for the em algorithm and k methods, you still need to initiate the number of clusters, so before you run the algorithm. So that's all. Thank you.